I would like to ask your permission for the recording of lesson 3 that will be on the IP addressing and some part of subnetting.
Okay, sir.
Okay,
Okay, sir.
okay.
Yes, sir.
Okay, so we'll start now our lecture on network technology, and we'll proceed with IP addressing. Okay, so this is an example of the internal on the connecting wires or the cable that you usually use when you buy a cable in the market. So you call it a UTP cable. So normally, if you say Ethernet, so you will find it in some computer store. But if you are going to buy like in shops, electronic shop, it's way cheaper. So you call it a UTP cable, and you will be asked what category you're going to buy. If you want a better cable, you will have a higher number. Nowadays, we have category 5, category 6, and category 8. So this is also, aside from this technology has been there for quite some time, like in 1990s. So this is unshielded twisted pair. It's the common media type used in local area network, and it consists of four pairs of copper wire with each pair tightly twisted together and contained in a plastic sheet or jacket. So another one we have communication medium is we have the fiber optic cable. It is extremely thin strand of glass to carry pulses of a light long distance at a high data rates, usually in large internetworks, and it's used to connect switches and routers and sometimes to connect high-speed servers to the network because of its capability to carry data over a long distances. The fiber optic cable isn't susceptible to electrical interference. So unlike UTP, it can be used to in electrically noisy environment. So now fiber requires two strands to make network connection, one for transmitting and the other for receiving. Now, the third one is this is one of the classic or the one of the oldest medium of network technology we use. We have a coaxial cable. So these are the parts of the coax, and this is used usually in the bus topology. That's why it cannot go further because of the solid wire conductor inside. It's a copper conductor inside, and once the cable has been damaged, so it cannot be easily replaced. So you will replace all the cable, or the distance that it could be used is until about 200 meters. So, and also the speed is very slow for this type of technology. Now, for the signal transmission, we have baseband and broadband. So, baseband transmission method sends signal in each bit of data represented by pulse of electricity. and or light. So when you say pulse of electricity, it's your copper media, and when you say light, it's more on the fiber optic media. So these signals are sent in a single fixed frequency using the medium's entire bandwidth. So in other words, when a frame is sent to the medium, it occupies the cable's entire bandwidth, and no other frames can be sent along with it. So it's like having a cable TV that carries only a single channel, and LAN technologies such as Ethernet and token ring use baseband transmission. If the cable TV used baseband signaling, you need uh, one cable for each channel. So thankfully now, cable TV and cable modem, Ethernet access use broadband transmission instead of the digital pulses. And broadband system use analog techniques to encode binary ones and zeros across a continuous range of values. Now, Ethernet is one of the popular, or we call this as many advantages. They use UTP cable also. It has advantages on scalability, media support, and it's low cost. And it support also broad range of transmission speeds from 10 megabit per second to 10 gigabit per second. And what makes it differs is that there are the cabling and the speed of transmission and method by which it is encoded. The bits are encoded on the medium because the frame formatting is the same. However, Ethernet variation are compatible with one another. That's why you often see network interface cards and Ethernet switches described as 10 by 100 or a 10 by 100 by 1000 devices. So these devices can support multiple Ethernet speeds because the underlying technology remains the same regardless of the speed. So we have this network reference model as compared to the TCP/IP model. So we have the Internet Protocol model compared to your OSI model. So we have 7 layers. We have the physical, data link, network, transport, session, presentation, and application. And we have from the Internet Protocol model, so we have the network access layer, and we have the internetwork layer, the transport layer, and the application layer. So the transport layer in both models are equivalent in the name and function. However, in TCP/IP suite, it contains the connectionless transport layer protocol (UDP), and which doesn't perform any of the function defined in the OSI model transport layer. So this one has a UDP on the transport layer. And on the OSI model, network layer is equivalent to the TCP IP internetwork layer. So all of these are network layer in OSI, while in TCP/IP, it's going to be your transport layer, and your internetwork layer works with UDP. And the OSI model divides the function of the network access layer into layers. We have data link and physical. So this is your network access layer. Now, if we are going to go with your computer, So how do we see your properties? So we'll try to show you how. Second. So for example, if you have your network and sharing center in your computer, you have to go with your connections. For example, you're going to click this one, your status, and you go with the properties. So what you have there, this one is an example that I made. So you go to your Wi-Fi properties and you will click IP version 4, and you could check if you want to obtain IP address automatically, or if you want to have it to name your IP address on a different address. So this is how you open your properties. But if I have a wired connection, it's going to be Ethernet properties. But since I'm using Wi-Fi, so now it's going to be Wi-Fi properties. The different from your computer that you're working on. We go back to our slide. So here we have the network transport layer. So these are your network transport layer. That is your IP version 4 and IP version 6. And you have also your session, presentation, and application layers. And your physical and data link layers are on your first search bar. So this connecting using, it means that you already have the driver of this connection. So this is your layer 1 and 2, and this is your 3, 4, 5, 6, 7. So that's it. Now for your transport model, so these are the functions that you will have. So it ensures a reliable delivery of data and breaks the data into segments and handles sequencing and acknowledgement and provide flow control. So at first, you will receive your device in the physical layer where you have the hardware connections and sending and receiving of binary signal, and also it handles encoding of bits. Now, for the second layer, so it provides the physical device addressing and device-to-device delivery of frames. Your physical address also is included, and the bits will be transformed into frame. And after it being transformed into frame, now it would be transformed into packets, and that would be on the network layer, which handles packet routing, logical addressing, and access control. And after that, it's going to be transported to the packet will be segmented and it would be delivered to the another layer. Now we have the following. So these are the IEEE 802 standards. So first, we have the I802.1. That is the standard for internet working. It covers routing, bridging, and inter-network communication. And also, it is the first standard that will be brought about on the technology. Now, after that, we have the 802 dot 2, that is your logical link control, and now it's already inactive. And the third one, we have the 802 dot 3. So this is the Ethernet LAN. It covers all forms of Ethernet media and interfaces, that is from 10 megabit per second to 10 gigabit per second, or that is what we call the 10 gigabit Ethernet. Now, for the others, there are some standards that are already disbanded. These are 802.4, that is token bus. Also, 802.6 was disbanded, and also 802.7, 802.8, and 802.9, and 802.10, including also 802.12. So these were not continued because they're preparing the standard for the future. So what is left now, we have 802.5. It covers all forms of talking ring media and interfaces. Also, we have now we have the 802.14, that is the cable modem. And Bluetooth is on wireless personal area network, that is 802.15. That's the Bluetooth technology. And now we have the WiMAX, the wireless metropolitan area network. It covers the wireless MAN, and we have also the resilient packet ring, that is 802.17. So it covers the emerging standard for very high speed ring-based LAN and MAN. And we have also 802.18, that is the wireless advisory group. That is a technical advisory group that monitors radio-based and wireless standards. And this one, we have also 802.19. So it's good that we are 50 plus. So later we'll try to simulate. Why is that going? There's somebody left. Okay. Now we have the future standards. So we have mobile broadband wireless 802.20, and we have 802.21 media independent handoff, and we have 802.22, that is wireless regional area network. So that will be used for those areas that's difficult to reach. And we have also 802.23, that is emergency services working group. It's used for emergency services like earthquake, and also we have this in our television now. When you have this option in your television, it would broadcast safety measure during like volcanic eruption, flooding, and other things. So this will handle emergency services. Also, we have as a summary the specification of 802.xx expanded the OSI model at the physical and data link layers. It shows how 802 standards provide more detail by separating the data link into these sublayers. Logical link control for error recovery, and also it's for flow control, and media access control is for controlling the access to the network media. So that's for the 802 standards. Now for the summary, so these are the summary. So most of the time I will have some questions on the summary slide. So you try to read all of this, and also with those having some indentation, italic, and bold style text. So those are some of the questions I considered in the test. Now for the IP addressing, so we have IP version 4 is a 32-bit number divided into 4-bit values we call octets. So each octet have a value from 0 to 255. That's why when example, we're going to write on our internet properties a distinct IP address, automatically what would be your value on your you have 255.255.0.0. So that's how the computer initiate the dotted decimal notation. This format consists of four decimal number. Each ranges to 0 to 255, and it's separated by a period. For example, we have 10.255.0.100. So what is your first octet? Your first octet is in this side. Your second octet would be this one. Your third will be 0. And your fourth octet would be 100. So in every IP address, it contains a network ID, and which specifies the network on which the computer is found, and a host ID, which uniquely identifies the computer on the network. So determining which part of IP address is the network and which part is the host ID depends on the subnet mask. So it's another 32-bit dotted decimal number, consists of a contiguous series of binary 1 digits and followed by a contiguous series of binary zeros. And this series of 8 binary ones equals the value of 255. Now, in this example, we have, okay, so example, you have a typical subnet mask of 255, or we have 255 dot 255.0.0, and corresponding octet of the IP address is part of the network ID. Now, we have now the subnet mask example. We have 255.255.0.0. So how do we have this number? So these are your binary number for 255, and this is the binary number for your second octet, that is your 255 also, and these are for your second octet, and your first octet. So that is 0, 0. So if you, for example, configure this IP address, so what would be your network ID? So your network ID would be 10.0.0.0. So this is your network ID and your host ID. What is your host ID? Your host ID is 1.221.101. So you have this. This is your host ID. Are you following? So this is your host ID and your network ID is this one and the 0.0.0. So you need network ID and host ID are used together when configuring a network computer IP address when communicating with one another computer. So the source address in a network packet being sent by the computer example is 10.1.221.1.101. Oh, that is your uh, source address. Now, for the second example, what would be your network ID? So this would be your network ID, the first two octets, and written as this one. And the second one octet is this one. Why do we have two octets? Why do we have two octets of the subnet mask as your network ID? Because this is a private internet protocol address, and also it depends on the class of IP address. So what is a contiguous network? So earlier we were talking about contiguous. So what is contiguous? So when a host of the network can access any part of the same network without going outside the network, that we call a contiguous. So there's a easy passing of information when you call contiguous. And example, we have this. Another example, you have 192.168.14.250. So what is the network ID? That is your 192.196.14.0, and your host ID is 250. And by the way, you cannot have a subnet mask of 255 because the network ID must be contiguous, or the data must flow easily on the connection or the communication media. However, you can have an IP address and a subnet mask such as a 172.16.67.5, and the subnet mask would be 255.255.192.0. What's going on the third octet of the subnet mask, even though this subnet mask doesn't look like other examples with only values of 255 and 0, it's still a contiguous series of ones which followed a contiguous series of 0. In binary, the subnet mask look like this. So this one, what is the value of this? Anybody? What is the value of this in decimal? Again, what is the value? So 255, that's correct. And also, it's going to be the same This one is 255, and uh, go back first. And this is also 192. So that's how this one is your subnet mask. It's the same as this one. And how we have those now values. So now we have to go with the calculation, and it's more on digital logic. So we have here logical AND operation. What is logical AND? If the input is the same, if the two inputs are the same, so you will have an output. But if the input is not the same, so in any case, you won't have output, and that would be zeros. And if you have the same ones, you have ones. So that's how we perform logical AND if there is the same. So you have how do you say this? 0 and 0 equals to 0. 0 and 1 equals to 0. 1 and 0 equals to 0. And 1 and 1 equals to 1. Now, how do we perform this? So, for example, where do we start? So, we will start at this side. This is your decimal point here. And you move to this side in order for you to perform the application of mathematics in binary numbers. So this one, 0 and 0, that is 0. 1 and 0, that is 0. And all of these, 0, correct? This one. So 0, 1, 1, 0, 0, 1, 0, 1, 0. So we have, since all of these are 0, so we expect that this would be also 0. But this one and 1. So 1, this is correct, yeah. And it's the same as this one. So the resulting subnet mask it would be 172.16.64.0. So that's how we perform binary math in the IP address. Any questions on this? And how about this one? After you perform and operation, you can see that the result, what we have in the previous slide was this one. And the remaining bits in the IP address that aren't part of the network ID and the host ID, in this case, was what are, so we have 3.5 or decimal 3.5, essentially where there's a 1 bit in the subnet mask that's correspond bit in the IP address are part of the network. Anywhere there are 0 bits in the subnet mask corresponding bits part of the host ID. So again, as I repeat, 1 bit in the subnet mask uh, represent IP address, and 0 bits in the subnet mask represent bits are in the host ID. So this one, which one is your host ID? So this one is your host ID, 0. Now we have some conversion that we will try to follow. So in this case, normally if you follow this, this would take long time. But for me, for easier slide, this is just by step. I will move to the next slide. So this one, when converting decimal to binary, so you have how many characters in binary? We have how many characters we have in binary?
Two, sir.
So we have two, correct? And in order for it to be identified, so this one, 2 raised to the 0 is, that is 1. 2 raised to 1 is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And 2 to the fifth is 32. And 2 to the sixth is 64. And 2 to the seventh is 1 to 8. So in this case, you will have values not exceeding 255. So you will not exceed to 255 using this 8-bit number or your octet. So meaning this is your digits in one octet. Are we clear? So
Yes.
this is how we test the numbers. Okay. So if 1, how do you perform this? So kung 1, 1 to 8 times 1, so 1 to 8 plus 64 plus 32 plus 16 plus 8 plus 4. Since 0, so you could not include 2. So and this one is 1. So what is the result of this value? 255 minus 2, that is, what is the result of this example? What is the value in decimal for this? 1, 1, 1, 1, 1, 1, 1, 0, 1. So that is 255 or that is 25 253, right? 253. 255 minus 2, that is 253. So did you get it? Why 253?
Yes, sir.
Okay. Okay, you could just see it na 0 na, so you won't add 2. Okay? So ang i-add nyo lang is 253. So I'll just write here. This one is this 253.
Ang sa babaw lang, sir. Ang sa mga 128, 160, 64, ito muna sa namin mo, sir.
Oh yeah, yes, because if you convert this 253, i-convert mo siya sa values. So you have how many?
255.
So
Sakto, sir.
255 ang total.
Oo.
So
Sir.
if the binary value is 1, 1, 1, 1, 1. So we have 1 and we have, sorry, 0, 1. This is
Oh.
binary. This is decimal. Okay? So given this number is 253 decimal, to convert it into binary, so remember that the total value we have is, kung 1 ni tanan, that is 255. This is
Sir,
255. Kung total,
excuse me.
kung 1.
Ba-
Kung 1 if this is 1, this is
255.
255.
Oo, ganun. Sir. Gets na,
Sir,
sir.
sir,
Yes?
bale kung may every value, kung may zero, sir, sa binary, automatic, sir, ang iyan na value, sir, i-minus mo, sir, sa 255.
Yes. For example,
Okay. Thank you,
if
sir.
this if this one is 1 ni tanan, di ba? 1. Ang value yan is 255. Okay? Kung this is 0, example, this is 0, so ang matabo, you will have sir. Okay. So for example, this is 255. So we need to find the value of 255. So what is the value of 255? So what is the value of 255? So that is easy. So we have, you need to add all of this. So this is 1, 1, 1, 1. So
8 ka
so
1,
remember,
sir.
so you remember you need to have 8 na 1, and you need to put this binary.
Oo,
This
sir.
is decimal, and this is your binary uh, 8-digit octet. So this is for 255. So 255 convert to binary, that's it. How about if you convert 1 to 8? 1 to 8 decimal to binary. So you have uh, that's only correct. You have 1.
1 lang, sir.
So 1 lang because you have 1 to 8 here. So
Sa
1.
baliktad.
So 0, 0, 0. So kung beginner pa ka mo learn about this, you need to put example, diri ka imo decimal point sa binary. So this is 1, 1, 2, 4, 8, 16, 32, 64, 1 to 8. So you put this. So this is your 1 to 8 binary, and this is 1 to 8, 128 decimal. Any questions?
Sir, ang question, sir. Nang may tendency or may possible, sir, ang sa dampi sa dalom, sir, ang sa 111, hasta sa 8 na, ang sa dalom, sir, may possible, sir, na 11101111, sir. Or ano gana, sir, pares na sa example mo, sir, hindi na sa matabo, sir, kadi, ano, sir, pwede sa matabo, sir. 111, so 0111.
1, ano to? 1,
Sir, may siguro, sir, kung fix na gid na ang digit, do sir nga 111101, sir.
ang ani, ang amo ni fix na example.
Kung sa dalawang fix na gid na, sir, nga
Ah,
111111.
Yeah,
hindi
depende sa value, sir.
hindi ni fix, hindi lang sa mag-exceed 255 dapat. Kay we are referring to 8-bit number. So until 1 to 8 lang gid until on this. So in any case, pwede ko katag example, i-convert niyo ang, I could give any as long as it will not exist. It doesn't exceed. I can have this example on the other slide.
Alam mo na tanan pamangkot, sir.
You could do anything. This value, for example, sa ano naman na sa binary to decimal na karon. This one is decimal to binary. Sa next naman na example.
Okay. Yes, sir.
So this one 0, 1, 0, 1, 1, 0, 1, and that's it. So in this case, what is your value for this? So since 1, you have 1 to 8 is okay. So 1 to 8, 0, x, hindi. This is 1. So x, wala. 16. This is x. Correct, correct, correct. So you have this, x, and this one is. So in cases, you have how
1
many
to
are,
3 lang, sir.
so
1
you
to
will add this
3, sir.
1, 2, this, and this. So that is 173. If you add it correctly, so you'll have the decimal value. So that is on binary to decimal. This one, we are doing decimal to binary. So this slide, this one is binary to decimal. Okay? So what we did here is from, erase it. We are referring to this one is decimal to binary. So this is decimal, and these are your binary equivalent. So this is okay. And for the next slide, we are on the we have the binary. This is reverse on the decimal. So the same what we did, we need to have this table in order for us to identify uh, which is the correct number or values. So this is a table 2, the same that we will not exceed to 1 to 8. So because we are on IP version 4, we are referring only to IP version 4, and this is 8-digit binary number. So write your binary number. Example, this one. This is our binary number. So if we write the binary number, how do we write? So if you are a beginner on conversion, you need to write on this is your least significant bit, LSB, and this is your most significant bit, MSB. Most significant bit, and you have the least significant bit. Okay? And you start writing your bit values from your right. So 1, 1, 0, 0. This is from here. Mukha mo na og salat. Okay, this one ay may decimal point na where we put the and we have this 1, 0, and 1. So the binary value that we need to convert is 1, 1, 0, 1, 0, 0, 1, 1. So this is the one below that we are showing. So how do we convert? It's the same what we did. So we multiply there are other cases also. Example, may man short method. Since we have a total of 255, what you will do, another shortcut, you will subtract the number which has 0. What are the numbers have 0?
32.
So
8.
subtract 32, subtract 8,
4.
and also
4, sir.
4. So, and what is the result? So
So 11, sir.
that would be your that will be your decimal number. Any more questions before we move?
None, sir.
None, sir.
Okay. So tomorrow we will have a short activity on this. Maybe I will do it in Kahoot para ma-practice. Pero I think you need more time, maybe 30 seconds or 20 seconds will do on the conversion part because you will use conversion on subnet mask. And if you're not going to understand this, it's difficult to pass the subject. Also to do your project.
Sir,
Yes?
pwede mo ni i-upload mo ni sir sa classroom, sir.
I will upload this sa YouTube. This.
Ang notes ya ba namin ko, sir? Ang
Oh,
notes.
i-upload ko. Ang lesson 3, once na we will finish lesson 3, i-upload ko nata ang lesson 3.
Okay, sir. Thank you, good sir.
Eh, wala pa natapos ang lesson 3. So, pag natapos ang lesson 3, ang lesson 3 lang i-upload ko para hindi na sa iba na notes. Okay? So, this one is the number. Okay? This is how you convert binary to decimal. Reverse and is it difficult or easy? So there are options. Okay? You have the subtraction and also you will have the long method that you will add it. Pero once you will see that it's not that really difficult, so you just be careful while adding the numbers. Okay? So we move to the next one. Okay, this is the IP address classes that we will have. So on your computer, you will try to go to, okay, so first we have, you go to Network and Sharing Center. And after that, you're going to click on your Wi-Fi or your Ethernet cable. Then after selecting your Wi-Fi or your Ethernet cable or Ethernet, you go to properties here. Once you open your Wi-Fi properties, so you will have to open this side and you will see the Internet Protocol version 4. So once you open this, you will have this example. And if you want to obtain IP automatically, so the computer or the interface card will generate it, and you will have this if you want a default IP address. So this is a private IP address, and also you could use DNS server. So address classes. So in communication between millions of computers and network endpoints, so around the world, we are using a common language which is called Internet Protocol. In this system, network endpoints such as computer, printers, cameras, mobile devices are identified by the IP address, in which it's fourth generation. We call it IPv4. The IP address are categorized in ranges referred to as Class A, Class B, Class C, Class D, or E. Take note, only IP addresses in A, B, C classes can be assigned to a network device. A, B, and C are used to be assigned to network device, although IP address class system has been superseded and by more flexible way to manage IP addresses called classless inter-domain routing. Nowadays, we don't have class A, class B, but there is already classless inter-domain routing, which part of IP address is the network ID and which part is the host ID. The first octet of the address denotes its class. So which is the first octet earlier? In our previous slide, which is the first octet? In this example, which is the first octet?
172.
Are you sure? So which is the first octet? Let's have some. Okay. Hey, this one. So which is your first octet?
255, sir. 255, sir.
So 255 or your uh,
8,
and this one, which is your first octet?
255, sir.
255 man Japon, sir.
255 ng Japon, sir.
Okay. So for this one, 255, and for the other one, we have 172. Excuse. And but nowadays, IPv4 is already having the most routing internet traffic, and it's going to be depleted already because there's already a new uh, so that's why, class, we have this format of all elements that represent 8 bits from values 0 and 1, which means that one element can appear in a 2 to the 8 version. As a result, you have a numeric system distinguished among 2 by 32 IP address. So we have 2 to the 8. So what is 2 to the 8? So this one, okay? So why 2 to the 8? 2 to the 7, sir? Because we don't count this as 0, but this is 1. Okay? So we have how many bits? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 bit for IP version 4. Okay? So we will do IP version 4. And because why it is depleted? Because there's already a worldwide web unexpected growth and network professionals are facing more and more issues. One of the problems is that the amount of distributed addresses is not enough. The second, the version of 4 IP address are being distributed and which, according to preliminary estimation, shall be used up within a short period of time. And the problem is that it doesn't support mobility, and it also not possible to have a support encryption built into the protocol. That's why if you have your phone, normally your phone will have your address that is in hexadecimal. And also, to solve this problem, IP version 6 was created, but the implementation of IP version 6 is complicated by the fact that the two versions are similar in many ways. They handle data packages transmitted through the network differently, hence they cannot operate concurrently. So that's the problem with IP version 4. Now, this example is a IP version 6. We have 128 bit version 6 address, usually represented by 8 groups of hexadecimal digit. So these are 4 hexadecimal digits. That's why you have 1F, C0, CCB. What is the digit here? 0. This is 0 CCB. Although you have seen 3, may 0 na di sa punta. By the way, the most significant bit, if it is 0, it's okay that it would not be displayed. Like this one, 100. So when you call hexadecimal, you call it by each digit. You shall not say this is 100 because this is hexadecimal. You say 100 hexadecimal. What is the subscript of hexadecimal? What is the subscript?
6 or 6.
16.
16.
So because you have 16 bits. So kung octal gani, we have example octal. Octal 8. Diba mo na? Kung binary 1 0 1. Okay. So that is this one is 16. Okay? And for your, so remember hexadecimal have 16 bits, and your octal have 8 bits, and your binary have 2 bits. And as a result, devices connected to the network will have a public and globally unique IP version 6 address that can be sent over the internet, and which renders network address translation service used by firewalls and routers and IP version 4 networks are unnecessary. This is needed because in this way, the central element of a subnet, for example, a router, would get only a unique IP version 4 address. Then, with the built-in function, it would give unique identification to each endpoint of the subnet, which whoever would be unique on the internet. So this is an example of IPv6. Can you try it on your computer to do this if it has? So para you will see how it goes. So you try to test. I test. Type test. So do you have IPv6? So if you try to do this, you type test dash IP v6.com. You will receive this information. And this appears to be my computer. Now we go to the categories. Why, sir, is it 192? Why we have 172? What are those numbers? So the numbers are classified into classes. So if you have values of your first octet, that is 1 and between 1 and 127, that is Class A IP address that is intended for large corporations and government. So Class A IP address example, we have this. So when you work, you notice Class A IP address is this one. And also, it can be the first address, that is 10.0.0.0.0, and this one is 10.0.0.1, and the last address is 10.0.0 and 10.255.255.254. This is for Class A. Now for Class B, so we have this one is 128 up to and 191. So this use into uh, in medium to large networks, Class B, and the IP address registry assigns the first two octets. So this is the first two octets, first two, 172.17. So what's the difference? Class A only assign at the first octet. So in this example, which is the first octet? First octet. The first octet of Class A on the example is
10, sir.
Ay, check ko 10.
10. 10. Okay?
10, sir.
So that's for Class A. For Class B, you have this one is your first two
170.
octets. Okay? First two
1
octets
to
are
8.
your
1 to
172, sir.
okay, 172.17 are your first octets. Okay? First two octets are your host address. And for administrator, you could assign as host addresses. So the network address for this example is 192, 172.17.0.0, and that is your having the two sets in the host ID allows you 65,534 hosts per network address. So that would give you a lot of hosts per network. That's for Class B. Now we go to Class C, Class D, and Class E. Now, for the Class C, uh, they intended for small network, like I always write in the board 192. So 192 is a small network, like laboratory. So Class C address is usually limited to 254 hosts. Okay? Now, take note, Class A, Class B, and Class C are used for networking, while Class D and Class E are not used. So these addresses are used for multicasting. What is a multicast? So multicast is when each packet is addressed so that more than one destination can receive. So application using this feature include video conferencing and streaming media. In a Class D address, the first octet is in the range of 224 to 239. Class D addresses can be used to assign IP address to host computer. So that's the reason why it was not used. And also, we have Class E. The value started from 240 to 255. And the first octet,
Ay, ciklod doon. Yung nga ng galabay sa likod ko mo.
this, this range is reserved for experimental use and can't be used for the address assignment. Okay. Now, this range of address is reserved for experimental use and it can't be used for address assignment. So, in summary, so this would be the end of our lecture for the IP addressing. So, these are the summary that you're going to have as a takeaway of this lecture. And so, we have the following. So, what have you noticed? The greater number of network bits, the lesser also your number of host or network. As you see, the number of host bits also are going lower. So, any questions on the lecture?
None, sir.
Answer.
None, sir.
Okay, so
None, sir.
we're going to end our lecture here, and maybe tomorrow we'll have to continue the since we have already dry run the Kahoot, so we'll use it tomorrow because we don't have enough time, and I think I already have discussed too much. So thank you for the for your for attending the class, and I'm going to stop the recording.